In this video, we're going to look at another example of a related rate problem. And this one looks at a construction worker that pulls a 5-meter board up the side of a building by the means of a rope tied to one end of the board. So if you look in the diagram, here's our little construction worker. He's pulling this 5-meter board up the side of the building connected to the rope. And we're going to assume the opposite end of the board follows a path that is perpendicular to the building. So what that means is down here, the bottom end is going to run perpendicular to the building. And the worker is going to pull the rope at a rate of 0.15 meters per second. And we want to know how fast is the end of the board sliding along the ground when it is 2.5 meters from the wall of the building. Alright, so let's kind of label what's given and what we're looking for. So we're pulling this 5-meter board. So we know the length of the board here is 5 meters. And he's pulling the rope at a rate of 0.15 meters per second. Okay, now if we're pulling this rope up here, then we're thinking this is going up at 0.15 meters per second. So this would, if that's the change here, if we think of this in terms of the units here, what we're looking at is 0.15 meters per second, and this would be equal to what? This is, what's the rate of change representing here? Well, if we kind of draw this and look down here and think of this as a triangle here, and think of your X and Y axis. If we think of this as your X axis and this over here as our Y axis, then we're pulling this rope at 0.15 meters per second. So that could really be representing our dy dt. In other words, here, the top of this board, this triangle that we formed here with the board against the building, we could think of this as dy dt here. Okay, so maybe if I label this better, we could say this is going to be dy dt is equal to 0.15. And that's here, if you think of this triangle, the y value here, since he's pulling up, this is going to increase. And it says we're sliding along the ground when the board is 2.5 meters from the wall. So as we pull, this board is going to slide along the ground, and we want to know what's going to happen when the distance here, when x is equal to 2.5. Now, what we're trying to find is what? How fast the end of the board is sliding along the ground. So how fast is the end of the board sliding along the ground? So this end of the board here, we know that if we pull, the board's going to slide in this direction to the left. And if we think of that as our x, then that means we're looking for dx dt. So we're looking at the change in the x value with respect to time. That's what we're trying to find here. So if we label this, we want to know what is dx dt. And once again, we are given, of course, we know that when x is 2.5, and we know that dy dt is equal to the 0.15. Now, if we look at this and think of this as a triangle, with our x and y on the board here, we form our triangle. what equation can we relate with this given information of an x value, dy dt, and the dx dt that we're trying to find? Well, if you said Pythagorean theorem, you would be correct. So if we want to find our equation here, we could then use x squared plus y squared equals the hypotenuse squared, which in this case would be 5. So we would have 5 squared. So here's the equation, and now we need to take the derivative. And if we take the derivative of both sides, again with respect to t, we would have the derivative of x, we would get 2x dx dt plus 2y dy dt. And the 5 squared, that's just 25, which is a constant, so that's going to go to 0. And now we have our derivative, and if you notice here, if we go to substitute now, if we're looking for dx dt, that's what we're looking for here, we would have 2 times x. Well, the x value, we want to know when this board is at 2.5 meters, so that's the x value. And then dx dt is what we're looking for, plus 2 times y. Now, we don't have a y value. We have the dy dt, which is 0.15, but how can we find the y value? Well, that's going to cause us to go over here and look at our triangle again. So let me redraw this. If we have our triangle, and we know that the x distance is at 2.5, and of course the board is 5 meters, so that's going to remain constant. That can't change. The board's not going to change length as we pull it, hopefully. And then of course we want to know the y value when this is at 2.5. So we know the x is 2.5, the hypotenuse is 5. So then if we want to find the value of y, once again we can use the Pythagorean theorem. X squared plus y squared equals 5 squared, and of course we know our x value is 2.5, so we can plug that in, and we would have 2.5 squared. And if we solve the equation, we're going to end up with y squared equals 5 squared minus 2.5 squared is 18.75. So therefore y is equal to the square root of 18.75. And of course we're looking at the positive value, so we can plug this in for our y value. We would have the square root, 18.75, and then we're going to multiply that by dy dt, which is 0.15. So now at this point all we have left to do is to solve the equation for dx dt. So if we do that, we're going to have to, well, let's see, this is all still equal to 0. So if you solve all this for dx dt, we would have 2 times 2.5. And if you take 2 times 2.5, you're going to end up with 5 times dx dt. And all of this, I'm going to move to the other side so we can subtract that away. So we're going to really end up with the 2 times 0.15, and that's going to be multiplied by the square root of 18.75. And if we move it to the other side, you're going to end up with approximately a negative 1.299. And if we divide all of this by 5. Then dx dt would be equal to a negative 0.26, and we're talking about meters and our time was in seconds, so this would be meters per second. Now if you notice here, our answer is negative. Does that seem to make sense? Well, if we go back up here and look, if this board is going to the left, we think that is our x direction, so therefore it is certainly correct that this would be a negative 0.26 meters per second. So with this example, realize once we took the derivative, we ended up with this 2x dx dt plus 2y dy dt, and we didn't have a value for our y, so we had to go to our diagram and see if we could figure out with the given information if we could calculate the value for y. And using the Pythagorean theorem, we were able to come up with the square root of 18.75. So that allowed us to find our dx dt.